Hello. Is my voice is audible? Good morning.
Morning, sir.
Morning.
Morning, sir.
So already I started recording. I am sharing my screen. Okay. Now tell me, my screen is visible to you? Say yes or
Yes,
no?
sir.
Oh, right. So up to the previous lecture, we was in the module 3. There we have seen the BJT, device structure, physical operation, concept of common base, common inter, common collector. We also have a transistor as a switch if you are connected in a saturation mode and the cutoff mode, it will work as a switch. That means a short circuit switch or an open circuit switch. We also have seen about the MOSFET, metal oxides, field effect transistor, how what was the device structure, the mode of operation, characteristic, and all, right? We have a MOSFET configuration along with amplifiers. Okay, so that we will see after one lecture. Today we will do module 5 because it's very small chapter that we can complete in 1.5 lectures. So first we will complete module 5 and then we will go for module 4. Okay, so today we will start module 5, that is based on digital logic. So let's start our new module, that is digital logic. Module 5, that is digital logic. On that, we have a first topic which covers number system. Okay, so as you all know about the decimal number system, so I'm starting with the number system. Okay, so all of you know about the decimal numbers. What are decimal numbers that we generally use in our normal life, right? So decimal numbers, which numbers which have a 10 digits starting from 0 to 9 to represent any number. For example, I am saying to represent 5695. Okay, so you can see this is 5, this is 6, 9, 5. All are the combination of digits, 10 digits starting from 0 to 9, right? So that means you can represent any number by combining these 10 decimal numbers starting from 0 to 9, right? For example, you have the same number, how I can represent it, right? So you, if I say, what is this number? You can say this is 5,000, right? 5,695, right? 90, right? Like this, right? Now I can also write down like this: 5 into 10 raised to power 3 plus 6 into 10 raised to power 2 plus 9 into 10 raised to power 1 plus 5 into 10 raised to power 0. Understand? So how actually we have written the number was 5695. It have some place value. Place value. What are these place value? Is having the place value of 0, is having the place value of 1, is having the place value of 2, and it's having the place value of 3, right? And as we are talking about the decimal numbers, if it is a decimal numbers and we have a 10 different numbers to represent any number, so its base is 10. Okay, base is 10. So if you want to represent any number, you can do one thing. Here is the place value, right? 0, 1, 2, and 3. So how you will do? 5 into, and this is the base. Base is what? 10. So you have to pay, assume R is 10. 10, and then the place value, that is 3 plus. This is the 6. 6 into 10. 10 is the base. all right? And the place value is 2 plus 9, then the base is 10, 10, the place value is 1, 1 plus 5 into 10. 10 is what? The base, right? This is base. The place value is 0, right? This was all about the decimal number system. We have so many type of number system, like we have a binary number system, which have a base 2. Okay, so I am starting from the binary number system. Generally, computer know only the binary number system. That means computer will work only on zeros and ones. If I am talking, this is the base 2. That means it have only 2 digits to represent any number. It have only 0 and 1 to represent any number system. For example, if I am saying the number is 20 and base is, for example, okay, I'm starting with very starting number. Suppose 8 is the number in decimal. You have to see the base. Base says it's a decimal numbers. Okay, so I can represent it as 1000 in the binary number system. I will tell you how to convert this number to this binary number, but how to convert this base is very important. Okay, and here you can see, as I am writing in a binary number system, is a combination of zeros and ones only, right? So that means with the help of only 2 different digits, I can represent any number, right? That's why it's called as the binary number system. The question arises, if you have any decimal number like this, how we can convert into the binary number, right? So what is the procedure here? For example, I'm taking, suppose 14 is our decimal number, and I want to convert into the binary number system like this. This is my first question. Okay, so what is the procedure? You have to take the decimal numbers here. Okay, and on what base you need to convert that number, you have to write down here, right? Now you have to start dividing this number, dividing. Okay, so if you divide 14 by 2, what you will get? 7, right? Any remainder is there, you have to write down here. As 14 is completely divisible by 2, so you will get what? 0, 0 as a remainder, right? Again, 2 is your base. This base will be same for all. Now if you divide 7 by 2, what you will get? It will go 3 times, and the remainder you will get as 1, right? Now again you have to divide it by 2. So if you divide 3 by 2, it will go only 1 time, and you will get remainder of 1, right? Now as this number is less than base, now you cannot divide it, right? So the number start from bottom to top is your binary number system. So the number is 1 1 1 0. 1 1 1 0 is equivalent to the 14 in decimal, is equivalent to the 1110 in binary. Understand? This procedure we have to follow if the number is greater than 1, right? That means if you have number like 14.125, so in that case you have to separate the integer value and the decimal value. Okay, so I solved for the integer value only. I'm not talking about the number which is decimal, right? So if, for example, in the same case, for example, you have this number like 14.125, how I will convert it to the binary number? This is in the decimal number system. Now I need to convert into the binary number system. How we will convert it? Okay, so procedure says you have to separate the integer and the decimal values. So I'm separating it 14, and the next number I'm taking as 1.125. Okay. So as we have already completed how to convert this 14 in the decimal into the binary, that is 1110, right? This will remain same. Now we will see how to convert our decimal number actually the decimal part of any number into the binary form. As you have seen for the
Sir,
yes,
sir, what here 10 signifies, sir? What it really means, sir?
10 is the 10 is the base. That means we have how many digits to represent any number. Like you can see in the binary, in the decimal numbers, we have 0 to 9 different numbers. 0 to 9. That means 0, 1, 2, 3, 4, 5, so on up to 9. So we have 10 different digits to represent any number. That's why it's called as decimal number. So base will be 10. As you can see in the binary number system, we have only two digits that are 0 and 1 to represent any number. That's why space is 2. Understand? So 10 is what? Different digits that we have to represent any number. So now we have already seen if you have an integer number to convert into the binary form, just divide it by 2 and check the remainder, right? If you have a decimal number and we need to convert into the binary form, how we will do it. Okay, this is in the decimal numbers. So what is the procedure says? You have to multiply with the base. Base is 2. That means you need to convert into the base 2, right? So what you do, multiply by 2. So what you will get? 0.25, right? Which you need to note down the integer value. Note down the integer value. Okay. So what is this integer value? 0. Now you bring this one here again. That is 0.25 multiplied by 2. What you will get? 0.5. Again, note down this integer value, that is 0. Okay. Again, you bring this one here. That is 0.5 into 2. So that will be what? 1.0. Note down this value. If you're noting, that means now it is only 0. If you note down this value, that means whatever left will be only 0.0. That means 0.0, or you can say 0 only. So if you multiply with 2 also, you will get 0 only. So now all the process will be 0. Means all the digit will be 0. So now that means here from the top to bottom, you have to note down the value. So that for 14, we already written 1110, that is for 14, right? Now for 1 to 5, the value will be 0, 1, 0, 0, 1. That is 0, 0, 1. And the rest of the values are also 0. You can write down 0, 0, 0, and so on, right? So this is the way how you can convert your decimal system into the binary form. Understand? We will solve some more question related to it. Okay, I'm giving you one example. Okay? Everyone try by your own. For example, you have 12.25. It is in the decimal number. Try to convert it to the binary form. Okay.
Sir,
Yes.
sir, can you scroll up a bit?
Yes. Yes.
They were right. Why another zero, sir? There should be only four, right? Only 0, 1, 0, 0.
So here 001. You're talking about these zeros.
Yes, sir.
So first 0 this one, second 8, third this one, and after this if you multiply with 2, okay, 0 multiplied by 2, you will get 0, 0, 0. And if you are adding it, means if you are placing these value, it will not affect your answer, right? 0, 0, 0 after decimal will not affect. Even if you not write, that's not a problem. Understand? Okay. So now you try with this question. This says you have a decimal number of 12.25 and you have to convert into the binary form. So what is the first procedure? Separate the number. Okay. What is that? You have to keep your integer number like this and the decimal number like separately. Now this is your integer number. So what you have to do? Divide it by 2. Start dividing by 2. So what you will get here? Tell me.
6.
6. Remainder is
So we are not dividing by 10.
Because this number is already in the base 10. We have to convert into the binary form. You have this means you need to convert this number into the base 2. Right?
Okay.
So that's why you have dividing it by 2. Now again you tell me the remainder, that will be 0. If you again divide
0.
6 by 2, yes. Now if you
3,
again
sir.
divide 3 and the remainder will be
0.
0. Again you divide it by 2. So what you will get?
1.
1 and the remainder will be
1.
the number from bottom to top will be what? 1 1 0 0. This is the binary form of this 12, right? Now you tell me for this one, that is 0.25. This is the integer, this is the decimal number. Okay, for this what you have to do, multiply by 2.
2.
So what you will get here?
0.5.
Yes. So what you have to keep note down, that is what, 0. Again you multiply 0.5 because it's less than 1. So multiply by 2. So what you will get it here? 1.0.
1.
Note down this integer, right? So this is 1. Now, as I noted this value, you have next value is only 0.0. So if you multiply by 2, you will again get 0. All value will be 0. So the rest of the number will be 0. So 0.25 you can note down from top to bottom. This is very important. Bottom to top and top to bottom. So this number you can write down as what? 0.01, and the rest number are zeros only. So right, if we will combine these 12.25, you can write down as 1100.01 and so on. So that was the procedure how we can convert a decimal number into the binary form. Now the next part is what? For example, you have any number like 1011.110. For example, this is the binary number, and we have to convert into a decimal number. That is the next question. As I told you, if you have a number like this and you have to convert into the binary form, you have to start dividing the number by 2 and multiply the number by 2, right? Now you see, what is this one? For this, again, I'm writing like 1011.11. That's it, right? One again, one more 0. That's it. This is the decimal point, right? First, you write down the place value of it. Place value. Place value. What is that place value? Place position. If this is the decimal, this place position is 0. This place position is 1. This place position is 2. This place position is 3. Right? Before decimal, the number, as you know, in the time scale, it will be negative, right? So it is -1. This is -2. This is -3. Okay. Now, this is the base, right? This is the base. So what you can do? 2, 2, 2, 2, 2, 2, right? That means 2 raised to power 3, 2 raised to power 2, 2 raised to power 1, 2 raised to power 0. Similarly, this is 2 raised to power -1, 2 raised to power -2, 2 raised to power -3. So what you have to do, multiply this number with this one. That means 1 into 2 raised to power 3 plus 0 into 2 raised to power 2 plus 1 into 2 raised to power 1. Subsequent number and place value you need to multiply plus 1 into 2 raised to power 0 plus 1 into 2 raised to power -1 plus 1 into 2 raised to power -2 plus 0 into 2 raised to power -3. Right? Now you know the procedure to solve, right? Further is what? This number is 0. This number is again 0. So you can keep aside. And the rest you write down. Like 2 raised to power 3 multiply 1. That will be 1 only. Plus 2 raised to power 1 plus 1 plus 2 raised to power -1 plus 2 raised to power -2. Now tell me the answer. This is what? 8 plus 2 plus 1 plus 0.5 plus 0.25. And you add it and tell me the answer. What is the answer?
10.75.
10.75, right? So
11.75.
understand this.
11.75.
Yes, 11. Now you see what is the procedure, right? If you have any number like any decimal number to binary, this is the procedure. That means we already seen for the decimal number to binary form. Okay. We also saw binary to decimal. Now, decimal, as you know, is a base 10. And the binary is what? Base 2, where we have only 2 digits to represent any number, right? In the binary, again, as you know, base 2, and we are converting it to the base 10. Now, you see the second type. What is that second type? For example, you have a octal number system. Octal number. Octal means what? It have 8 digits, 8 different digits to represent, right? So that means 0 to 7 is the number to represent any number. Means 8 digit we have to represent any number. Starting from 0, that means 0, 1, 2, 3, and up to 7. We have 8 digits to represent any number. So if you have any decimal number, for example, you have 1, 2, 3. For example, no, I'm not taking more value. I'm just taking suppose 31, right? In the decimal, and you need to convert into the octal number. Octal says we have only the digits starting from 0 to 7. Understand? Procedure, as you already know that if you have any number in the decimal like this, and you need to convert into the binary form, how we did? Just divide it by 2, right? And we was checking the remainder here. The same procedure you have to follow it here. That means the procedure will be remain same for converting any number from decimal to any other base. Decimal to any other base. Either it is binary, octal, and we will have a hexadecimal and all other bases. The procedure will remain same. Only you have to check the base, right? The base value is very important. Here you was dividing with the base only when we was converting the number into the binary form, right? Here also you have to keep your base very important, right? That means you have to write down this number 31, and this place that base value you have to write down here. Again, divide it by 8. You tell me how many times it will go and what will be the remainder. Tell me, anyone? How many times it will go? It will go 3 times, and the remainder will be what?
7.
7.
7.
Right? So again, is it as the number is smaller than 8, now it will not go, right? So even if you write down, it will not divide this number. So from top to bottom, sorry, yes, from the bottom to top, okay, will be the number. From bottom to top will be your octal number, right? That means 31 you can write down as 37 in octal. Okay, now in the same case, I am saying, for example, you have 31 point, suppose anything like 1, 2, 5, like this you have, right? This is in the decimal numbers, and you need to convert into the octal. How you will do it? Separate. The procedure is remain same, okay? Only the base value will change. So what you will do? Separate 31 and separate decimal numbers. That we already seen. 31 is 37 in octal. That we already octal. That we already seen. Now you tell me what will be the procedure to convert this decimal value. So 0.125, you need to multiply with a base value. Which base value? 8. There we was using 2, right? If you remember, you have to multiply with a base value. So here it will be 8. Now you tell me if you multiply 0.125 by 8, what you will get?
1,000.
1.000. Okay, that means you have to keep this value here. Right? That will be what? 1. And the right, this is 1. Now if you multiply this 0, because you already noted this value, right? You already noted this value. So it will be what? Again 0 only, multiply by 8. So you will get 0. And the rest will be, rest the value, right? It will be 0. So the number will be 37.1 in the amount. Okay. Now we already okay. So this was the procedure to convert in any decimal into the octal, right? Now you tell me if you have any number like octal. In octal we have 1, 2, 3 in octal, for example. Okay, and you need to convert into the decimal number. You need the you know the procedure. Okay, what is that procedure? If for example it's 1 2 3 sorry 1 for example you have 1011 in binary and you need to convert into the decimal. Okay, what procedure we opted? You have to write down the place values. Okay, for example this is 0, this is 1, this is 2, this is 3, and write down the base 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, and then multiply with their subsequent values. Same procedure we need to follow here, right? 1 2 3 is the octal, and we need to convert into the decimal. You write down like this 1 2 and 3. Write down the place value. What is this place value? 0. This place value 1. This place value 2. And for example you have like 1 2 3 here also. So it will be -1. This place value is -2, and this place value is -3, right? I'm talking about this decimal. Okay, so according to this decimal, this will be 0, this will be 1, this will be 2, and this will be in the negative side, the negative scale. So it will be -1, -2, -3. Now, as this is in the base 8, you need to write down like 8 raised to power this, 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 8 raised to power this. Then you start multiplying this number with their subsequent numbers, like 1 multiplied by 8 raised to power 2 plus 2 into 8 raised to power 1 plus 3 into 8 raised to power 0 plus 1 into 8 raised to power -1 plus 2 into 8 raised to power -2 plus 3 into 8 raised to power -3. Now you tell me the answer. That will be in the decimal. Tell me the answer. Tell me the answer, anyone?
Sir,
This is still solving.
What, 37? What is that?
Still solving, sir.
Okay, still so.
So is it 83.162?
64, this one, then this will be 2 into 8, that is 16 plus 3 plus and so on. So I think
Yes, sir. 83.162.
83.16 to something like that, right?
83.38.
83.38. Okay, you just need to numerically solve this one, right? Now, the next thing that we have is the third type of number system, which is hexadecimal. Now, as the name indicates, hexa means 6, decimal means 10. So total we have a 16 different digits, 16 different digits to represent any number. Hexadecimal means base is 16. Now question arises, we have only 0 to 9 numbers to represent, right? We don't know any other number system, other digits to represent. So what it will take, 0 to 9 it will take directly from 0 to 9, and 10 it will assume as A, B, C, that is 10, 11, 12, P, 13, E, 14, and F, 15. So 0 to F is your total digits that we have to represent any number. Understand? In hexadecimal, we have total 16 digits, different digits. What is that? 0, 1, 2, 3, 4, up to 9, then A, B, C, D, E, F, up to F, that is 15. Okay. For example, I am saying you have any number like in the decimal first I am telling you. Okay. For example, you have 153. Okay. This is in the decimal and you need to convert it to the hexadecimal. What will be the procedure? Tell me the procedure first. You need to divide or multiply. First, you tell me divide or multiply.
Divide.
Divide, right? So you have to write down 153 here, and the base value you have to write down here. That is 16, right? Now you divide how many times it will go and what will be the remainder?
9 times and 7.
9 times and 7. Is it correct?
Sir,
I think this remainder is wrong, right? You tell me.
sir, what I was saying is
9 times and 9, sir.
9
Nine
times
reminder,
and
right?
9 reminder.
Reminder, yes, yes. Now, anyone was asking some question. Okay, so
sir,
what
why
will
are
be
we dividing this, sir?
what? Repeat your question.
So why are we dividing, sir? We should multiply here, no, sir, because the base here is less than the other one.
It's
Here
not
it
like
is 10
no,
and
no,
the
no. Listen, see. This is the procedure to convert it. It's not like based on base, right? Any number, if any number is in the decimal, how we will convert into the hexadecimal or any other base? The procedure will be like this. If it is integer, you have to divide it by that base, and if it is in the decimal number like 1 to 5 here, then you need to multiply it, right? It's not depending on the base. So here you have to take from the bottom to top. The number will be 99, right? For example, you have again this 99. I'm saying in the hexadecimal, how you will convert into the decimal number system. Tell me the procedure first. You have to write down 9 and 9, right? What will be the place value for this one? Place value will be what? 0, and this place value is 1. Now, as you know, this is the base 16, so it will be 16 raised to power 1. This will be 16 raised to power 0. Now you can write down as 9 into, that means multiply with their subsequent numbers. 9 into 16 raised to power 1 plus 9 into 16 raised to power 0. Tell me the answer.
153.
153. Now we checked also that if, sorry, 153. We checked also if you are converting this number to hexadecimal or hexadecimal to this number, it will remain same, right? That is 153. Now, that means if you have any number like, I'm giving you an example, like if you have 153 in decimal, that was the prescribed number that we saw, that binary we saw, then we have decimal, then we saw octal, we also saw hexadecimal. But we also have some decimal number system which are not prescribed. It says only, for example, you need to convert into the base 5, right? It's not having any prescribed number system. They say convert into base 5. That means they said R is 5. That means what? We have only 0 to 4, if 5 different digits to represent any number system, right? So what will be the procedure? You have to write down 153 here, 5 you have to keep it here, then start dividing the number, then you write down the remainder here. Okay, you do it fast and tell me the answer for this question.
One 103.
Okay, if you divide it by 5, what you will get here? 30, and the remainder is 3. Tell me, I'm just solving like this. Tell me, is it correct? Anyone?
Yes, sir.
Yes,
1103, I guess.
1 minute, huh? 13 to 5 is 150, right? So it will be, if you again divide it by 5, what you will get here?
6.
6, and the remainder will be
0.
0. So the answer will be 603. 603 will be in the base 5.
No,
Understand?
sir, you can still
No, again we can.
still divide it further.
Yes. You can divide it further. So what you will get here?
You get like 1
One.
and 1.
And the remainder is 1.
1103.
1103 is the answer. 1103 in the base 5. Now, for example, in the same question 1103, I gave you in the base 5. Can you tell me the number in the decimal? How you can do it? Just write down this number 1103. Write down its place value. For example, this is 0. The place value is 1. This place value is 2. This place value is 3. Now you write down the base around it 5, 5, 5, 5, and just multiply this number with 1 like this. That means 5 into raised to power 3 into 1 plus 5 square into 1 plus it is 0 into something, that means only 0 plus 3 into 5 raised to power 0. So it will be 125 plus 25 plus this will be 0, right? And this will be 3. So total answer will be 153, and that is the same answer that we calculated, right? That means we recheck this answer. Even if in the exam you can recheck, right? Your answer is correct or not by converting back into the base number. Understand? Now we saw about the octal and hexadecimal, right? For example, you have any number like BD, okay? BD in hexadecimal, and they said convert into the octal. So you know the procedure. What is that procedure? First, you convert into the decimal. That means base 10. You know this procedure, right? How to convert hexadecimal into the base 10. And you also know the procedure to convert into the base 10 into the octal. Okay, so like that also you can do. But if you have this example, for example, you have this type of answer, you can do one more thing. What is that? BD in hexadecimal, how to convert into the octal? That was my question, right? Every digit of octal is a combination of 3 digits of binary. Every digits of octal is a combination of 3 digits of binary. For example, if you have any number like a 7, 2 in octal I'm talking, right? And you need to convert into the binary form. that you can do it directly. Every digit will be the combination of 3 digits of binary. 7 you can represent as 111, right? And 2 you can represent as 010. So the total number will be 111010. That means separately you write down this 7 is what? If you divide it 7 by 2, what you will get here? You will get 3 here, then it will remainder is 1. Then if you again divide it by 2, you will get it will go 1 time and the remainder is 1. That means you can represent 7 by 111, right? So that's why separately you write down for 7, separately you write down for 2. That will be the number in binary. Similarly, every digit of hexadecimal is equal to 4 digits of binary. That means if the same number, if I take BD is in the hexadecimal, and they said to convert into the binary form. Okay, as I told you, one procedure says either you can convert into the base decimal, that is decimal number, and then you can convert into the binary form. But there is also a procedure by which BD, which is the hexadecimal, every digit is represented by 4 digits of a binary. B, as you know, 0 to 9. After that, 10 was A, 11 was B. Okay, and 11 in binary can be write as 1011. If you remember, you can do one thing. If you're not able to write down directly, you can do one thing. You take 11 because B is what?
Sir,
11.
wasn't 11 equal to 8?
Yes. What? No. See, 0 to 9 we have a number. For 10 we are using A. For 11 we are using B. For 12 we are using C. 13 is D. 14 is E. And 15 is F. Okay. 0 to F we have total 16 digits. That's why it's a hexadecimal. Okay. So actually B is representing 11. Right? You can do 11 separately. 11 separately you can convert into the binary form and write down in 4 digits. So if you divide it by 2, because we need to convert into the binary form, so it will go 5 times and the remainder is 1. Again you divide it by 2, it will go 2 times, remainder is 2. Again you divide it by 2, it will go 1 and remainder is 0. So the answer is what? 1011. So every bits you can represent by a 4 digit of binary like this. And D is what? D is 13, right? That you can represent as 1101. You can solve it, 13, how you can convert into the binary form. Take it 13, convert into the binary form. Remainder is 1, then again divide it by 2. It will go 3 times, remainder is 0. Like that, you solve it, you will get what? 1, 1. So it will be 1, 1, 0. Like that. So what? We have a decimal number system. We convert into the binary form like this, and the number is what? 1011. And for BD, I can write down 1101. This is in the binary form. Now my question was what? You have to convert into BD into a octal number. And as I told you, the octal number is a combination of 3 bits of binary, right? 3 digits of binary. So you combine the 3 digits, 1, 2, and 3. Here we don't have any number, you can assume as 0. Okay. Now you separately write down the number here. 101 is what? 5. 111 is 7. And 010 is 2. So 275 is the answer for this question. Understand? So either you can follow this rule. First you convert into the decimal, then go for octal. That is the one procedure. Either you can follow the second rule, by which any digit of hexadecimal is actually the combination of 4 bits of binary, and octal is the combination of 3 bits of binary. Like that also we can follow. Okay. Now I'm telling you about the complements. Okay, we saw already the okay. 1 minute. I'm opening one new PDF. Okay, up to that time you do one thing. You take one example and try to solve this one. You have 1, 2 in the decimal, convert into the binary form, convert into the octal form, and convert into the hexadecimal. That is your question and try to solve it. Till that time, I'm just opening my new PDF. You note down 12 in the decimal, you need to convert into the binary, octal, and hexadecimal. Okay, so we have I asked you a question. That means we have a 12 in the we have 12 in a decimal number, and you need to convert into the binary number, then you need to convert into the octal number, then you have to convert into the hexadecimal. Can you do that? Tell me, what is the value in binary form? 12, you need to divide it by what value?
2.
2. So what will be the answer?
2, sir.
It will go how many times?
6.
It will go 6 times, and the remainder will be 0. Then again you divide it by 2. So the number you will get is 3, and the remainder is what? 0. Again you divide it by 2. So it will go 1 time, and the remainder is 1. So the answer is what? 1, 1, 0, 0. Now you have to convert into the octal number. Can we do directly? Can we do directly? As you know, the 3 bits of binary is actually the octal. So what I will do, I'm just changing the color to represent it better. So what you can do, you can combine these 3 bits starting from the last one. Okay, don't start from the starting bit. From the least significant bit, combine 3 digits, and then again 3 digits. As you can see, we don't have 3 digits. You can add 2 zeros to make it 3 digits. Okay. Now, as you know, 100 is 4, 001 is 1. So this 14 is in the octal is your answer. Okay. Now I'm writing the same here, 00110 like this. And we need to convert, this is the binary form, and we need to convert into the hexadecimal. How we will do it? As I told you, the 4 bits of binary is actually the hexadecimal, right? So now again, I'm changing the color to show you better. So you can do one thing, you combine 4 bits like this, and we don't have any bits because all are zeros. We can write off 0, 0, right? Everything is 0. This is what 1100, it's 12, right? The problem here is what? In hexadecimal, I can represent 12 by which alphabets, right? If you remember, up to 9 is same, then 10 is A, 11 is B, 12 is C. So as the number is C, you can write down C here. C is the answer. Understand? Now, I have to explain you about the addition and the subtraction. Okay. So for this, I need a 1s and 2s complements. Yes. Anyone having any answer? Question?
Convert 14 base 2 to hexadecimal. So why? Sorry, 14 base 8.
What happened? See, we was having the 12 in the decimal. You need to convert into the binary form. So I did like this, right? The procedure is same. Then as I told you, if you need to convert binary into octal, you combine the 3 digits of binary. So as you can see, these are the 3 digits, these are the 3 digits. So this is 1 and this is 4, right? How? You know the place value, how to convert the binary into decimal. So
Yes.
this play, okay, so this is 1 and 4, 14 we got. So this is octal, okay? If
Yes.
we have binary form of it, you can convert into the hexadecimal directly by combining the 4 bits. So we was having 00 and 1100. From the least significant bit, combine 4 bits. So it's 001. Only one thing you need to keep in your mind, that combine 3 bits of binary will give you octal starting from least significant bit. Similarly, if you are combining 4 bits of your binary, it will give you hexadecimal, but you need to start from the least significant, right?
Yes, sir.
So, okay, one more topic that we have is the logic circuits. Okay, so let's start with logic circuit.
The time is up.
Okay, time over. Okay. Okay, so we will do the rest thing in our next class. And if you have any extra lecture free, you tell me. So on that, we will do the numericals. Okay, it will be benefit. It's good for you. So if any lecture is free where we can take, we can do some numericals. Tell me. Okay, you decide with your own, and you tell me any 1 hour. So on that, we will do the numerical. Okay.
Yes,
If
sir.
any lecture is there, then you tell me before the exam. That will be good for you. We can cover the syllabus, but problem is if you solve more numerical, then you will get more idea about the numericals. It's better, right? So you tell me any free lectures, I will take, right? Okay. Thank you. Thank you from my side. Yes, I will share this PDF to you. Okay, so I will share, and now you can leave. I will take that attendance directly from here. And before next exam, you tell me 1 hour lecture. Okay, yeah, we can solve some numerical based on these numbers. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.